So we're going to hand over to Maria, who I think is about to terrify us, as I said. So yeah.
That is the goal.
Yeah.
Thank you. Hello. My name is Maria Lowe, and I'm a senior software engineer at Confluent. Confluent is a cloud services and software company whose cloud-native platform is designed to unleash real-time data. Powered by Apache Kafka, the platform acts as a central nervous system in companies, letting them connect all their applications around real-time streams and react and respond intelligently to everything that happens in their business. My job in the UI Foundations team is not only to help build the UI for this software, but to make general improvements across our front-end code base to make other developers' lives easier. Now, one of the things that I've seen people struggle with over the course of my career, including myself, is displaying times and dates to users around the world, and I'm here today to warn you exactly how difficult that can be. So, out of interest, who here has struggled with time zones? Lots of people. Understandable. For those of you who haven't yet had the pleasure, let me explain why they're awful. So they are, useful for people the world over so that they can say that their morning starts at 7 a.m. rather than 3 p.m. or midnight or what have you. But if you've had to deal with them in software, it gets complicated. And to explain why, let's explore what happens if you build a website that people all over the world can access and use, but you start off ignoring that time zones exist. Let's say you're building something that lets you schedule events in advance and keeps a record of all the events you've ever scheduled, a calendar, basically. And because you're ignoring time zones, you might decide to send the start and end times of the events to your server as strings that look something like this. You might be thinking, I'll store my times and dates as lovely human-readable strings, so when I'm populating the view for my website, I can just use those strings directly. Job done. But your first problem here is a lot of string formats are actually quite ambiguous. For example, while a user in the UK would read this as the 3rd of April, a user in the US would read this as the 4th of March. And is this 2:30 in the morning or 2:30 in the afternoon? So to avoid ambiguities like these, we can instead use a widely adopted international standard, say ISO 8601, which would now make our string look something like this. Our strings are now written as year, month, day, a capital T between the date and time parts, hours, minutes, seconds. This is now unambiguously the 3rd of April at 2:30 in the afternoon. Great. But what now happens when users in different countries try to use our site together? Imagine that this website has a user in the Netherlands who tries to join an event scheduled by their friends in Finland at 8 p.m. But by the time they show up, the event has already finished. The problem is that the Netherlands is in a different time zone to Finland, and these are 1 hour apart. When the person in the Netherlands tried to attend the event at 8 p.m., it was already 9 p.m. in Finland. So how can we fix this? We now know that we need to start caring about time zones, so we are going to have to keep track of time zone differences somewhere. You might think, we'll try to collect this information ourselves. For example, we could get our users to pick their current offset from UTC, that's short for Coordinated Universal Time, in a drop-down, ranging from, plus 12 to minus 12 in lovely 1 hour increments, and use that to work out what time to display. And this will be fine, because time zones are lovely and consistent, right? Well, as you can see from this map, not only are time zones not nice straight lines across a world map, the UTC offsets are not even a whole number of hours. That is Nepal up there at plus 5 3/4. Countries within one zone can have entirely different offsets from each other. Individual countries can use multiple different time zones. And the international date line is not even a straight line. The UTC offsets on this map range from -12 on one side to +14 on the other, with all sorts of fractions in between. This drop-down is going to get very, very long. And if you thought all that was bad enough, a lot of, but not all, countries observe daylight savings time. It doesn't have a fixed start or end date. It does not start at the same time worldwide. And it doesn't always move the clocks forward by exactly 1 hour. Trying to take all of this into account yourself is going to be an absolute nightmare. So don't. Use either your language's built-in datetime functions or use an open source library that will handle all of this for you. For example, JavaScript has the open source library moment.js, Java has the inbuilt API of java.time, and Python has the open source library Pendulum. However, there may be smaller libraries out there that will still do everything you need while being better for other reasons. Another popular datetime library for JavaScript is datefns, which is about the third of the size of moment.js while having almost all of the same functionality. So when picking what software you're going to use to help you with this, do some research. There may be more than one good choice out there. Just figure out what will suit your needs best. You will also need to pick a standard way of storing all of this information so that you can easily convert it between your users' local time zones. You absolutely do not want to be storing it in your users' local time zones, as you'd have to store the time zone as well, convert or parse it every time you're pulling this data out to do a comparison between two users' different sets of data. So save yourself the headache and store everything in UTC. Trust me, you'll thank me later. So now that we've decided we're going to store everything in UTC, you'll notice our string from earlier now has a Z at the end. This is shorthand for saying that this time is in UTC. And so if we want to convert this to the equivalent time in, say, London, we can pass it to our library of choice. I've chosen JavaScript's datefns just for an example. We'd pass it like this and format the output, which will also automatically assume that we want the time in the user's local time zone by default. You can see that because of daylight savings, meaning that we're currently in British summertime rather than Greenwich Mean Time, this time was actually 3:30 p.m. in the UK, and the library has correctly calculated that for us. Handy. Now, I've only been talking about string formats for time information so far, but another major thing to consider when dealing with dates and times is what format you should be using to store and send them. Using a standardized string format like ISO 8601 will work, but a better alternative is using Unix timestamps. So what are they, and why might you want to use them instead? Well, they are the number of seconds, or milliseconds, but we'll stick with seconds here, since the epoch, which is a defined reference point in time, defined as midnight on the 1st of January, 1970 UTC. So, for example, the date and time we've been looking at so far would look like this as a Unix timestamp. Now the why. Because Unix timestamps are numbers, they take up less space than their string equivalent, and so take up less space to store and are faster to send across the wire. Maybe not so relevant if you're only sending a few, but can become very relevant if you have a lot of data. When storing dates and times in databases, take care to use the database's own type for this. It will most likely be called something like timestamp or datetime. It should be as efficient, or almost as efficient, as storing it as a number, but will also come with some added benefits, like indexing, human readability when looking at data, and the ability to easily convert the data to a Unix timestamp when you need to retrieve it. It will also let you write database queries against those dates in a more human-friendly way. For example, you can query for all the events scheduled in the last year without needing to create a timestamp for the date a year ago, and then compare that to your data. They're also much easier to do direct comparisons on. With timestamps, you can use your basic less than, more than, and equals operators and compare them that way. But with strings, you'll need to import and use a datetime library or API everywhere you want to compare them, complicating the process and adding another place to potentially introduce bugs. Finally, consistency. As long as you're consistent in picking what your number represents, be it seconds or milliseconds, you won't have to worry about mixing string formats up. Not just in your API, but, for example, between multiple different user interfaces. You could have both a website and a mobile app, and if you're using strings, you'll have to store exactly what string format you're using in both of these places, and if you make a typo in either of them, then suddenly your strings aren't formatted properly in that place. Oops. This is even more important when you consider that not everyone using your software is necessarily going to speak English. You are going to want to display dates not just nicely and in a human-readable way, but possibly in lots of different languages as well. So being able to reformat your timestamps into strings without having to worry about what format the string you're receiving came in, or that making a mistake when parsing the string could just break everything, is very handy. And that is the end of my talk. Thank you so much for listening. This is a list of links to some of the resources I used when writing this talk. In particular, the problem with times and time zones video is an incredibly relevant rant about how awful time zones are, just as relevant today as when I first watched it. I highly recommend looking that up and giving it a watch. It's very funny. And thank you again. Any questions?
Can you hear me? Mm-hmm. Anyway. Yeah, for the room. What's this? Oh, it's on now. Deciding of which of the 100 questions I want to ask, because I have many. The main one is, how do I convince other engineering teams that caring about time zones and daylight savings is, pun intended, worth their time? Because the amount of wasted hours twice a year whenever daylight savings changes between 1 and 3 weeks differently, to the point where there's an hour for 3 weeks where nobody's on call because the US haven't started and we haven't finished. So it's one of those, it happens every year, but no, it only happens for a brief amount of time, so nobody cares about it 2 weeks later.
I mean, gosh, that is a tough one. It's almost more a sort of process question, I guess, with how does your company handle general problems that are sort of little niggles, but regular little niggles. I guess if just pointing out that this is a consistent issue hasn't worked, possibly worth pointing out, well, what happens if, say, the UK decides to abolish daylight savings? At what point? What's going to happen then? Like the US, you know, there's, can't remember if it's the whole of the US or a state, but there is somewhere in the US that is currently talking about abolishing daylight savings. Like, these things are not constant. Even within one country, daylight savings time is not going to be guaranteed to be a thing forever. So perhaps pointing out that even in the future, we could stop having daylight savings, something might break even worse, might be something that would help your argument.
I've got a related one. It's similarly as Daniel's from a personal pain point. Twice a year, our collective schedules get absolutely ruined, and they don't get consistently ruined, because going back to your calendar example, if I'm sitting in the UK and I book a weekly meeting at, say, 5 o'clock in the afternoon, and then another colleague in the US books a meeting every week for, say, what time zone that's going to be, we'll call it by 10 a.m. their time. And these meetings don't touch each other. No touching until all of a sudden for 2 weeks they're now on top of each other, and then another 2 weeks later in the year they're now an hour apart, because the calendar systems presumably are going based on whoever created the event. If you were going to express an authoritative opinion, how would you solve that?
Oh my word. See, I actually also have a similar thing because most of my company is based on the west coast of the US. I actually find this sort of 1 or 2 weeks twice a year a boon because the only meetings I have are with them, and then suddenly for 1 or 2 weeks twice a year, they're all an hour earlier, which is great. I love it. Gosh. Again, I feel like that's almost more of a sort of social process question than a time zone question, but I guess making people aware of it, that this is a thing, is probably a good first step. They may not even know. Honestly, people just assume that daylight savings is just a thing that happens at the same time everywhere. I get people in the US going, oh, haven't your clocks changed yet? And no, they haven't. And, no one realizes until you talk to each other about it. So I guess making people aware that this is an issue, again, because of, it doesn't happen at the same time every year. I guess having some kind of maybe a company wiki that just lets people know when these weeks are coming up, that people need to be mindful of overlapping meetings. I think communication is going to be key here. Maybe some things will have to get shuffled around, but you're going to have to talk to each other to solve it. I think that's your only solution.
Thank you. I think Bolster's bigger problems is organising meetings for 5 p.m. Thank you very much, Maria. That was great. Yeah, it's a nightmare. So thank you, and yeah, some great suggestions in there. All right, if you want to.